All right, today we're going to start working on lesson 3.2, and we're going to focus in today on conditional statements and related conditional statements. We're going to look at some of the ways that we write conditional statements, how we draw conclusions, and then some of the variations that we use of these conditional statements. So, first of all, as we've already talked about, a conditional statement is a statement that can be written in if then form. Okay, so there's two parts to the statement. There's two statements, I guess, involved. So in this case, our first statement is it rains on Saturday. Our second statement that we're calling Q here is the parade is canceled. So I have two statements that are either true or false. So they are statements. And when we join them together with if then, we form this idea of a conditional statement. So the conditional statement P implies Q would be if it rains on Saturday, then the parade will be canceled. Okay. So the part that follows the if, the statement P, which is the statement that follows the if, we call the hypothesis of this conditional statement. And the statement that follows the then the parade will be canceled. The parade will be canceled. The Q here is called the conclusion of the conditional statement. Okay. So we talk about hypothesis and conclusion. Okay. So it's P implies Q is how we write it with notation. And then we can logically determine if this is true or false. Okay. And we'll look at some of those today as well. But we're going to look at conditional statements today and also how to write them and identify the parts of them and then work with some of the related conditional statements. All right. The related conditional statement concept is taking the original conditional statement. In this case, we had P implied Q, right? Which was if it rains Saturday, then the parade is canceled. And we look at rearranging P and Q and negating P and Q in different ways to create other arguments or other conditional statements. So to find the converse of a conditional statement, we are going to interchange the hypothesis and conclusion. So rather than P implies Q, we're going to say Q implies P. So if the parade is canceled, then it rains on Saturday. Excuse me. Now, we can argue whether this is true or false all we want, and we'll look at some of these in a minute. Okay. But if we assume this is true, if it rains on Saturday, then they're going to cancel the parade. Okay. That's just going to happen. Then is this always true? If the parade is canceled, then it must have rained on Saturday. Well, it's not, because there's other reasons the parade could be canceled other than the fact that it rained on Saturday. Okay. So the hypothesis and conclusion, the order of these two does make a difference. All right. We also will look at the inverse of a given conditional statement. And the inverse of a statement is when we go back to the original, we negate the original hypothesis, and that implies the negation of the original conclusion. So the way this would look is if it doesn't rain on Saturday, then the parade will not be canceled. Finally, we have what we call the contrapositive of a conditional statement. And for that one, we take the converse and we keep it as is, and we negate them both. So it's the negation of Q implies the negation of P. So this one we would write, if the parade is not canceled, then it doesn't rain on Saturday. Okay. So these are all conditional statements. Okay. Just different ways of taking an original and rearranging them. And you're going to have to do this tonight, but you get drop down menus. It's pretty basic. Okay, one thing we know about these, though, is the original statement and the contrapositive are always going to have the same truth value. All right, so if it rains on Saturday, the parade is canceled. Let's say that's a true thing. If it rains, then the committee is going to cancel the parade. Down here, if the parade isn't canceled, then it didn't rain on Saturday. Well, that's true, because if it doesn't rain Saturday, they're not going to cancel the parade. All right, so if the parade isn't canceled, then it didn't rain on Saturday. Okay, the converse and inverse are always going to have the same truth value. If the parade is canceled, then it rains on Saturday. Well, we said, there's other reasons they could cancel the parade. In the inverse, if it doesn't rain Saturday, then the parade will not be canceled. Well, we already said that there's other reasons they could cancel it other than the rain. So the converse and inverse are going to have the same truth value. The original and the contrapositive are going to have the same truth value. Okay. And they can be a variety of different ways that this works out. Okay, let's start with the basics here. Consider this conditional statement. If a person is a professional skier, then the person is a professional athlete. Okay, so our hypothesis is the person is a professional skier. Our conclusion is then that person is a professional athlete. And I would say that's true. If you're a professional skier, skiers are athletes, then you're a professional athlete. Okay. Now, the first thing says is give the converse of the statement. So remember, the converse is when I take the conclusion and make it the hypothesis, and the hypothesis and make it the conclusion. So the converse of this statement would be if a person is a professional athlete, then the person is a professional skier. Now, if we were asked truth value, I'd say that's false. Not every professional athlete is a skier, but every professional skier is an athlete. So this one I could say is false. B, write the inverse. Okay, the inverse says go back to the original and negate each of these two. Leave it in the order it's in and negate them. So if a person is not a professional skier, then the person is not a professional athlete. Okay, the original order, negate them. And then contrapositive, take the converse and negate it here. So if a person is not a professional athlete, then the person is not a professional skier. Okay. So that you're just dropping down and you're identifying the hypothesis conclusion and putting them in the right positions. Okay. All right. We'll do it again here. If a person is pregnant, then the person is a female. Okay. So hypothesis, a person is pregnant. Conclusion, the person is a female. Okay. The converse, well, interchange these two. If the person is a female, then the person is pregnant. Write the inverse. Excuse me. The inverse. So take your original statement and negate them both. So if a person is not pregnant, then the person is not a female. And then the contrapositive is to take the converse and negate these. So if a person is not a female, then the person is not pregnant. So that's how we write the converse, inverse, contrapositive. Okay. Now let's look at these statements and then determine the truth value. So the table at the right shows the shape and the color of toy blocks that are sold in the set. Okay, these are the only toy blocks in the set. So the circle's red, the star's purple, the clover's red, the square's green, and the triangle is blue in every case. So we give a conditional statement. We're going to write the converse, inverse, and contrapositive, and then we're going to decide the truth value using this chart. So first statement, if the toy is a clover, then it is red. Then the block is red. Well, every clover is red. So that's true. Okay. Now let's write the converse. Converse is to take the conclusion, make it the hypothesis, take the hypothesis, make it the conclusion. So switch the statements. So if the toy block is red, then the toy is a clover. Now, this has to be true all the time. And in this case, it is not because we do have red circles as well. Just because it's red doesn't mean it has to be a clover. It could also be a circle. So this is false. This is a counterexample. All you need is one counterexample to make the statement false, and there it is. All right. The inverse. Take your original statement and negate them both. If the toy block is not a clover, then the toy block is not red. Well, again, this is false because if it's not a clover, that means it's a circle, star, square, or triangle, and the circles are red. So it could be red, even though it's not a clover. So this is false. And then the contrapositive, okay, we go to the converse, right, and negate them both. If the toy block is not red, then the toy block is not a clover. So if it's not red, that means it's purple, green, or blue, and none of those are clovers. So this is true. So remember, the given statement and the contrapositive, same truth value. Converse, inverse, same truth value. Okay. I think I gave you another one here. So in this case, the table at the right shows the material of each item in Amy's jewelry box. And these are the only items in it. So the bracelet's made of gold, the ring is silver, the pendant platinum, the necklace is gold, and the hairpin is copper. Okay. So we got to identify here in these which one of these is made of which material. So here are our statements, right? The given statement, and then we're going to figure out its truth value using this. So the given statement, if an item is a bracelet, then the item is made of gold. So the bracelet in her jewelry box is made of gold. There's no other bracelets here. It's the only one. So the bracelet's made of gold. That's true. Okay. Converse, interchange these two. So if the item is made of gold, then the item's a bracelet. So if it's gold, these two are gold. Does it have to be a bracelet? No, it could be a necklace. There's your counterexample. So that's false. Inverse. If the item is not a bracelet, then the item is not made of gold. So if it's not a bracelet, which means it's a ring, a pendant, a necklace, or a hairpin, then it can't have gold in it, which is false because the necklace has gold. Contrapositive, right? We're going to do the negation of the converse. So if the item is not made of gold, then the item is not a bracelet. So if it's not made of gold, that means it's silver, platinum, or copper, and none of those are bracelets. So that's true. Okay. So there's how we can write these conditionals, determine true, false, and we have to be given something here to work from. Okay. The last thing we're going to look at is taking our concept of conditional statements and using three statements together to write the statement using symbolism. So, for example, each part below, fill in the symbolic form. So we want to write the symbolic form. And we're going to use some grouping symbols here because we have three statements. We have to know what goes together first and then what's applied to it second. So it is Tuesday or Jane is in history class, comma, if and only if Keith is not jogging. So the first part, it is Tuesday or Jane is in history class, that's going to be in grouping symbols. If and only if is going to be my symbol I use. Keith is not jogging. Okay, so it is Tuesday is R, or Jane's in history class, that's Q. So it's R or Q in parentheses. If and only if Keith is not jogging. So Keith is jogging his statement. So I want the negation of that. So it's going to look like this: R or Q. So it's Tuesday or Jane is in history class. If and only if, that's when the arrow goes both directions, the negation of P. Keith is not jogging. Okay. If Keith is jogging, then Jane is not in history class, comma, and it's not Tuesday. So if Keith is jogging, then Jane is in history class. That's a conditional statement. So it's if P, then negation of Q, because she's not in history class. That's in parentheses. And it's not Tuesday. So P implies negation of Q. So Keith is jogging implies Jane is not in history class. That's in grouping symbols. And it's not Tuesday, negation of R. Okay, so you got to group it. I give you another one here. Same concept. Okay, if we are not going walking, then it is fall. So if then is conditional, right? So that's going to be in grouping symbols, comma, if and only if the sky is clear. Okay, so if we are not walking, that's negation of Q, implies it's fall, P, in parentheses, if and only if the sky is clear, that's R. Okay, so you got to group it, make sure you're using all the correct symbols. We are going walking, comma, or if the sky is not clear, then it is not fall. So we are going walking is your first statement, or is the conjunction, and then this part's going to be in parentheses. So we are going walking is Q, or in parentheses, negation of R, the sky is not clear, implies negation of P, it is not fall. So you got to track these carefully, but you can see commas are helping us separate with grouping symbols. Okay. All right. So that's it. That's working on the related conditional statements, looking at some, being able to write them in symbols and then looking at some truth values of them. All right. So your homework is on, Alex, and I will let you get at it.